Hi. As you know, digital electronics is one of the important subjects in the GATE syllabus of electronics, electrical instrumentations and computer science syllabus. And if you see the entire content of the digital subjects, K-map is one of the important chapters among all. And there are two reasons for this why K-map is one of the important chapters. Number one is its weightage is quite good. If you refer the previous year GATE question papers of any streams, you will find good number of questions from the concept related to K-map. That's number one. And number two is its application in the entire subjects. So, like let it be combinatorial circuits, sequential circuits, logic gates, more or less wherever we have the situations, we have to minimize some Boolean functions. K-map is one of the most preferred methods, right? Because of so many advantages. It is very systematic and quickly get solutions, so on and so forth. So, and again, if you see the question paper of GATES, and particularly if you see what kind of questions are coming from K-map, okay, so there are basically two model of questions are coming from the K-maps. So model number one is some information will be given to us and will be asked to find what is the minimized expressions. So they may give us mean term, max terms, or they may give us the map itself or something like that, directly or indirectly. Some information will be given and will be asked to find what is the minimized expression for the given Boolean functions. That's model number one. And model number two will be again some information will be given, maybe mean term, max terms, or some way they will be giving, and they will be asking us to find how many prime implicants are there and how many essential prime implicants are there for these functions. So these are the two model of questions we are getting in the GATE exam frequently. And in fact, related to K-map, there is no third model. Any questions, if it is from K-map, it will be coming on any of these two models, right? But answering the model 1 questions are pretty straightforward. Somebody should know how to do the groupings and how to write the expression for the group cells. That's it. That's very straightforward. And answering the second model questions are a bit tricky, right? So because the reason is students get confused which is prime implicant, which is essential prime implicant, how to distinguish them, right? So this is a bit tricky. And so I'm going to tell you now the complete details of prime implicants and essential prime implicants. I'm very sure if you watch all videos of these concepts, prime implicants and prime implicants, in future if you are writing any exams or if you are attempting any questions which are related to prime implicants and prime implicants, you are not going to miss that. So let's get started. So prime implicant and essential prime implicants. Shortly we say PI. PI stand for prime implicants and EPI stand for essential prime implicants. Okay. So what are the various concepts I am going to tell you under this particular subtopic, PI and EPI. So the first one we should know is what are PI and EPI. So that's number one. Number two is how to find number of PI and EPI. That's number two. Number three is application of PI and EPI. And number four is assignments and its solutions. Assignment and its solution. So basically this last segment is I can say this is nothing but your problems based on PI and EPI. Okay. So I'll make one video for this. This is part 1, and one video for this. This is part 2, and one video for this. This is part 3. Okay, so watch these 3 videos, and I'm very sure, and after watching this, so there won't be any doubt for you if the questions belongs to this PI and EPI concepts. Okay, so let's get started. So first one is, let's see what are these PI and EPI and how to find number of PI and EPI. Now to explain this, so let me take one examples. So let's say I'm taking one example. So this is your example 1. Okay, let's assume that we have a 3 variable Boolean functions f of ABC And let's say for this, the mean terms are given to us, which is 0, 1, 2, 6, 7. Okay. And the question is to find how many number of prime implicants are there, how many number of essential prime implicants are there. So let me explain this, and in the explanation itself, I'll be defining you the definition of PI and EPI. Okay. So for that purpose, what we have to do is, first of all, we have to draw the K maps. So this is 3 variable K maps. So in a 3 variable K maps, there will be 2 raised to power 3, 8 number of cells. So these are the 8 number of cells. And if I take this side is A and this side is BC, A is the MSB, C is the LSB. So this cell is for mean term 0, 1, 3, 2, 4, 5, 7, 6. Or you can plot on your way, whatever the way you use to write this. Okay. So if I'm plotting this, so this is mean term 0, this is mean term 1, then this is 3, then this is 2. I don't have 4, I don't have 5, I have 6 and 7. So 7 here and this is 6. So this is the plot of K map for this function f, right? So with respect to these functions, I have to find how many PI, how many EPI. I'll be giving you the definitions, okay? But now notice carefully how to define the prime implicants. See, whenever you used to solve the questions for minimization problems, suppose if I would have asked you, what is the minimized expression of this function f, and you have decided to solve it using K map, let's say, what you would have done? So hopefully you might have done like this. So you'd have done this, right, grouping something like this. So I have this 1, 1, and this is 1, and this is 1, 1. Okay, this is what the map is. So suppose if I ask you to find the minimized expressions, you might have gone for the groupings. So you should have first checked whether octet is possible, octet is not possible, whether quad is possible. No, I don't have quad also. Then I should go for the next thing, that is pair, that is group of 2 cells. So is there any possibility? Yes. So this is one possibility. This is one possibility. But you know, like my requirement is what? My requirement is I have to group all the mean terms if I am grouping the mean terms, right? So I have done this and this, I am left out with this. Now I can do the grouping of this. So I would have stopped here. And I would have said this is what is the corresponding answer. I will be writing the expression for this, this, this. And if I want to write in the soft form, so I will be getting the answers, right? So I would have stopped here. But the point is, so while dealing with this PI and EPI concepts, we are not supposed to do like that. We shouldn't stop here. We have to go further more, right? So what is the further more thing we have to do is, along with this, I should also check for redundant groupings. So redundant grouping means, so even if furthermore groupings are not needed, still I will be going for the groupings. But do remember one thing, I should be doing the grouping in such a way that a complete group, okay, a smaller complete group should not be in a big group. So what does this actually mean? This means, now you see, so if I ask you, so is there any other grouping possible? Even if redundant, you please do that. So obviously I can make a grouping of this and this. Okay, but then again some people might have doubt. So if I are doing this and this, then can I take a grouping like this? I cannot take grouping like this. That's what I am telling you. So while dealing with this, you do the grouping and grouping, but make sure a smaller group should not be completely inside a bigger group. So notice here, if I am making this as a single group, so this is complete inside this bigger group. But what is this? This and this group, is it complete inside bigger group? This group, if you see, this is covering what? This and this. So it is not like that this is being accommodated in a completely a bigger group. That's not happening. So that's what you should be able to distinguish. You are not supposed to do the grouping like this. Similarly, you should not do the single grouping, because if I do that, then what I am doing is I am putting a smaller group complete inside a bigger groups. That's it. So now in this, whatever the number of grouping I have done, so those represents prime implicants. So suppose if somebody will ask you how many number of prime implicants are there, then you should check how many number of grouping you have done. So this is group 1, okay, this is group 2, this is group 3, and this side one is group 4, okay. This is group 1, this is group 2, and this is group 2, this is group 3, and this side one is this group 4. There are 4 prime implicants. So number of prime implicant is 4. So basically what is prime implicant? Somebody asks you, this is the maximum number of possible grouping that can be done in a K map, including the redundant group. But while doing the redundant group, I should always make sure I am not putting a smaller group completely inside a bigger group. So that is what you should be careful. Okay. So number of prime implicant is 4. Then I want to answer how many number of essential prime implicants are there in this particular map. Okay. So how to find this essential prime implicant in this sense is, now you have to check each and every prime implicants. Okay, you have to check each and every prime implicants, And what you have to do is, you have to check, is there any mean terms which is not covered by multiple groups? Is that group is containing at least one mean term which is not covered by multiple groups? If it is being satisfied, I'll be telling yes, it is a essential applicants. If it is not satisfying, it is not a essential applicants. What you understood? I think nothing, right? See, what I mean to say is, I will be taking each and every group now and I will check whether this group is having at least one mean term which is not covered by multiple groups. So let's say if I am considering this group 1. So group 1 having two mean term, this and this, but this mean term is covered by two groups. I mean this group as well as this side group, right? But this mean term is not covered by multiple group. This mean term is covered by only one group. So this particular group is containing one mean term which is not covered by multiple group. So this is what is the requirement for EPI and it is satisfying. So I will be saying group 1 is a essential prime implicants. Then I will come into group 2. Group 2, if you see, this is what is the group 2. This vertical one is I am telling group 2. See, in group 2, how many number of mean terms are there? I have two mean terms, right? This and this. So this mean term is covered by how many groups? Two groups. This one and this side one. And this mean term is also covered by two groups. This one and this one. So this is containing two mean terms and both of the mean terms are covered by multiple groups. But my requirement is it should have at least one mean term which is not covered by multiple groups. So like this case, out of two, one of that was not covered by multiple groups. So I said it is EPI, but in this case both of them are covered. So obviously it is not qualifying the character of EPI. So 2 I am crossing. It's not API. What about 3? 3 if I check, again it is having two mean terms, this and this. Out of 2, this mean term is covered by multiple groups or two groups, but this is not covered by two groups. So this is covered only by this one. So this group 3 is containing at least one mean term which is not covered by multiple groups. So this is satisfying my requirement. So group 3 is also a EPI. Now the next thing is, what is group 4? What is group 4? So group 4, if you see it here, so what I can say, group 4, if you see the group 4, so this group 4 having how many mean terms? So two mean terms and both of the mean terms are covered by multiple groups. So this mean term is covered by two groups and this mean term is also covered by two groups. So this group 4 is also not a EPI. So only group 1 and group 3 are EPI. So the number of EPI in this case is 2. I hope this is clear, right? Now, if it is clear, now let us answer one more example, which is example 2. So basically, let me summarize what I have done. So actually, to find this PI and EPI, I have first plotted the K-map, then I have done the groupings, but I have also done the redundant groupings. Redundant grouping are those groups which are not necessary for minimizations, but still we are doing that. So we have done that, and while doing that, we have made sure we are not putting a smaller group completely inside a bigger groups. So by doing that, how many number of grouping I have done? So that is what representing PI. In this case, it was 4. And then among all those PIs, then I should check each and every PIs whether it is EPI or not. Now, what is the condition I am putting for this? I am checking, is this group is containing at least one mean term which is not covered by multiple groups. Okay, if yes, it is qualified to set to be API. If no, it's not API. So by taking that, so two groups we have discarded, so they are not API, remaining two are API. So number of PI is 4 and number of API is 2 in this case. Now let's take one more example, which is my example 2. Okay, in example 2, so this functions f of a, b, c. Okay, so let's say the mean term I am giving is 0, 1, 5, 6 and 7. So the mean term I am giving is 0, 1, 5, 6, 7. Instead of 2, I am saying it is 5, right? So if I ask you to plot this map, how does this map will look like? And one more beautiful conclusion also I will give you based on these two examples, which will be definitely helpful for you in case if you get some tricky questions. So let's plot it. So this is cell number 0, cell number 1, then 3, 2, 4, I have 5, then 6 and 7. So this is 7 and this is 6. So this is what the map is. So again, my requirement is to identify how many PI and how many EPI. So I should be going for the groupings. I can make grouping like this, I can make grouping like this, and I can make grouping like this. Okay, so if my job is to get the minimized expression, so I might have stopped here. But now to have this PI EPI discussions, then I should also go for some more grouping which are redundant. So is there any other grouping possible? You should do the grouping in such a way that you are not putting a smaller group inside a bigger group completely. Then obviously this is one possibility, right? Is there anything else possible? No, I don't see there is any other possibilities. So obviously in this case also, how many grouping I have done? I have done total 4 grouping. So let's say this is group number 1, this vertical one is group number 2, and this is group number 3, and this is my group number 4. So the number of PI is 4. Then my requirement is to get how many number of EPI are there, right? So I should check. Group 1 is EPI or not? Yes, out of 2 mean terms. So this is one mean term which is not covered by multiple groups. So yes, group 1 is EPI. What about group 2? Group 2 having 2 mean terms, and both of the mean terms are covered by multiple groups or 2 groups. So this is not API. This is containing 2 mean terms, and again both of the mean terms are covered by multiple groups. So this is not API. What about group 3? Group 3 also, if you see, it is containing 2 mean terms. Both of the mean terms are again covered by 2 groups, this group and this group. So again this is not API. What about group 4? Group 4 is containing 2 mean terms, and out of 2, this is shared by 2 groups, but this is not shared by multiple groups. So this is containing at least one mean term which is not covered by multiple groups. So group 4 is also EPI. So the number of EPI is nothing but equals to 2 in this case. Okay, having said this, now let me take one more examples, which is example 3. And in example 3, I am not giving the mean terms. Now directly let me give you what is the map itself, and my question is to find how many number of PI and how many number of EPI. Okay, so this is what is the map, let's say, given. Okay, and the question is to find how many number of PI and how many number of EPI. Then again in this case I should be going for the groupings. So again, group of 8 is not possible. Group of 4 is possible or not? Yes, possible. So I should go for the quad or group of 4, right? So this is possible. Then to cover this, so I should be going for this one. That's it. Is there anything else possible? Then if you say, no sir, I will be doing like this, like this. So if you somebody say like this, I am doing it. So if I am doing like this, if I are putting a pair, that means what is happening? So that group is complete inside this quad, right? So that's what we are not supposed to do, right? So I cannot make the grouping like this, like this. Okay, so that we are not supposed to do, because we have the restrictions. We are not supposed to put a smaller group complete inside a bigger group. So how many PI are there in this case? So obviously the number of PI is nothing but equals to how much? So how many group I have done? I have done 2 groups. So the 2 PI. So this is group 1 and this is group 2. So we have 2 PIs. Now next thing is, how many EPI are there? How many essential implicants are there? Then I should check to have number of EPIs. I should be, checking whether this is qualifying to be EPI or not, this is qualifying to be EPI or not. How do I check it? To have this, what I should say check is, so among all 4 mean terms, is it containing at least one mean term which is not shared by multiple groups? So if you see this, out of 4 mean terms, only one mean term is shared by 2 groups, this mean terms, but remaining 3 mean terms are not shared by 2 groups. So this quad is containing 3 mean terms which are not shared by multiple groups. So this is satisfying criteria of API or not? Yes, it is API. And what about group 2? Among 2 mean terms, this mean term is shared by multiple group, but this is not shared by multiple group. So this is group 2 is also containing one mean term which is not shared by multiple group. So this is also API. So number of API is 2. Now here in this question, some students get confused. They count here, it is 3. So why they count it is 3 is, they say 3 mean terms are not covered by multiple groups. So number of API is 3 plus 1, they say it is 4. But is that correct? Now do remember, we are not counting how many number of mean terms are not covered by multiple groups. That's not the definition of API. So you should see the overall group, and in that overall group, is it containing at least one mean term? In the previous example, it was only one mean term, but in this case we are getting 3 mean term. But that doesn't mean that we will be counting it is 3. It has to be counted 1 only. So the overall group should be counted as 1 only. So obviously, so this group is also containing at least one mean term which is not from multiple groups. So that is also said to be API. So number of PI is 2 and number of EPI is also 2. Okay. So this is what example 3. I hope I am able to explain you the concept of PI and EPI. Okay. One more interesting thing I'd like to tell you in this case. Okay. So what is that? Now suppose in this, okay, so in this case, okay, this is what one grouping we have done. This is what one grouping we have done. We have done grouping this and this we have done, right? Okay, this is what we have done, and from this map only we have given the answers, right? Now the point is, now suppose somebody asks you to get the minimized expression of this map, right? See this carefully, this is a good concept. This is 1, 1, 1, 1, 1. We have already said regarding this PI, EPI, but I am showing you one more aspect of it. Okay, so 3 examples I have given. Now this is what one observation I would like to give you. Okay, what is the observations? Let's see. So I am explaining these observations with respect to these examples only, right? So this is the map I have taken. If I ask you to get the minimized expressions, you will be doing grouping like this, you will be doing grouping like this, or you can do grouping like this, right? So this is one options. Then somebody can also do a grouping like this. So what they will do is, so they'll be doing, okay, so we have, this is the map, so they'll be definitely doing, this is one group and this is one group. Now I have to cover all min terms, so they may do the grouping of this. So in both of the cases we have covered all the min terms. And okay, so let's name, this is group number 1, this is group number 2. Okay, and here if I name it, so this is group number 1, this is group number 2, and this vertical one, let's say group number 3, and this horizontal one, let's say it is group number 4. This side group I am saying group number 4, and the vertical one is 3. Now for this map, if I ask you to write the minimized expressions, so what are the terms you will get? So this is 1, 2, and this vertical one I said 3, so I have group number 3. In this case, I have, this is group number 1, this is group number 2, and with respect to this side one I have said it is group number 4. Then somebody, if someone will write the minimized expressions, so this function will contain the expression corresponds to group number 1 plus group number 2 plus group number 3 in this case. Or if somebody prefer to do the grouping like this, so this minimized expressions will contain group number 1, the term from group number 2, and the term from group number 4. Now if we combine both of this and this, what I can say is the minimized functions f should be containing group number 1, group number 2, then it is group number 3 or group number 4. Group number 3 or group number 4. So this is what is the overall functionings. Okay, so that means what is being actually happening is this group number 1 and group number 2, so these are nothing but your EPI, essential prime implicants, and these 3 and 4, these are nothing but your PIs. Okay, now it makes sense. Like one conclusion we can make from this is the expression whatever we will be getting from the K map, that's not necessarily to be unique, because if somebody will write the expression for this, you'll have something for this third one, and if somebody writes for this, you'll have something for this one. I mean, the two terms in both cases will be same, but the third term, if you compare both of the expressions, will vary. So the number 1 conclusion is the expression from the K map need not to be unique. That's number 1. And number 2 is the minimized expression of K map contains all the essential prime implicants and optional prime implicants. If somebody says it contains all the prime implicants, that need not be true. But if somebody says it contains all the EPIs, then it is 100% true. And why it is 100% true? It makes sense, because if you leave that EPI, then that min term cannot be covered in any other way. So it makes sense that we should definitely cover all the EPIs, but not all the PIs. So let's write that conclusions. Conclusion 1, okay. The expression from K map, need not be unique always. Conclusion 2. The minimized expression of K map, contains the term, the minimized expression of K map contains the term corresponds to all EPI and optional PIs. Okay. The first conclusion is expression from K map need not be unique always. Second conclusion is the minimized expression of K map contains the term corresponds to all EPI and optional PIs. So in other words, the minimized expression will contain definitely all EPIs and it should contain few PIs, not necessary that all the PIs. So these are the two conclusions. Hope this concept is clear, right? Now let me give you the statement for PI and EPI. You can note it down for your future reference. Well, these are the statements of the definitions of the various terms I have explained. Prime implicants. It is the maximum number of groups made by considering the redundant groups, but while doing so, a smaller group should not be present completely inside a bigger group, right? And essential prime implicants. EPI are those PIs which contains at least one mean term exclusively. So these statements I have explained to you by taking 3 examples. I hope this is clear, so you can copy down these definitions. Next thing is, in any K map, number of PI is greater than equals to number of EPI. Hope this is also clear to you, because we are first finding PIs, then from those PI list we are checking or basically we are discarding or not discarding. That depends on whether it is satisfying the criteria of EPI or not. So it makes sense that the number of PI will be definitely greater than or equals to number of EPI. Let's say in one case you are getting that all the PI are EPI, then in this case you will get equality. Otherwise you will always be getting like if all PI are not EPI, so obviously in that case the number of PI will be greater than number of EPI, like we have seen the cases 4-2 kind of things. So example 1 and example 2, if you remember, so their number of PI was 4 and number of EPI was 2. This was for example 1 and example 2. But in example 3, number of PI was 2 and number of EPI also 2, right? So you can also see from these examples, and it makes sense, it has to be true, because we are first selecting PI, from there we are discarding. So it may happen EPI will be less or at max they will be equal to, but number of EPI will never be greater than number of PI. Next, in any K map, if all PI are EPI, then the minimized expression is unique. I hope this is also clear, because if all the groups are representing EPI, then what does this means? That means all this grouping contains at least one mean term which are not covered by other groups. So it makes sense, like in that case it will be unique in nature. In other words, there is no other way, or there is no other groups which can be grouped, or which can group all the mean terms. So it makes sense, like in any K map, if all PI are EPI, then the minimized expression is unique, right? So in these cases, like I have shown you in one examples where I have taken like group 1 to 4 and group 1 to 3. In that case, the number of PI is 4, number of PI is 2. So in that case, we are getting it was not unique. I said there can be 2 expressions. I have given the conclusions. The minimized expression of K map need not be unique in nature, right? But this statement says, in any K map, if all PI are EPI, then the minimized expression is unique in nature. Okay? So this is what is the what is PI and what is EPI, and how to find them, how to find PI and EPI from K map, I have explained. In the next video, I am going to tell you what is the applications of PI and EPIs. Thank you.